Good morning, good afternoon, good evening, good night, whichever one you're seeing. But welcome back to Fun with Learning. Today we're going to do forces and energy. So this is going to be a three-part video. This is part one. First part we're going to be talking about density. So let's get started. So let's start by learning what mass volume, because that is what's important for us to find out what is density. Okay, let's start. Now let's start with mass. So mass is how much matter a thing organism has. So mass is the amount of matter. Yes, for example, take your body lotion thing. It has some atoms we zoom in. So the amount number of all of the matter is when you use matter there, you get your mass. Actually, misconcept mass as well as weight. But to honest, mass is kg, while weight is actually newtons. So say in scale you are 45, so 45 kg by newton. Now, why in newtons? You know, newtons is something that's related with force. Right? Means here, weight shows the number, the force that the gravity applies on an organism or thing. Then take your body or something, and the force that's been applied by the gravity. So that force that's applied by the gravity is called the weight. Body number matter is in hands, called the mass. Now what's volume? Volume is space the thing/organism takes up. What is here? Now we're taking a bit of space, and the amount of space that it takes up is volume. Space that the thing, the matter that the thing takes is the volume. Now when we take a small part of this and the matter with volume, when the matter is taken, when how much matter is in a specific area, how much matter can be taken per specific area. So now to calculating the volume and the density. So now let's say we're going to find a density of a cuboid. A cuboid that has length 2, breadth with 2, height 2, and height 3 with 1. Let's say 2, 1, 3. Yeah. Now we need to find the mass and the volume. Let's have a mass. And we're putting in a weight. Now let's say the cuboid weighs around 2 kg. No, let's say the 2 kg would be okay. Now let's say now volume can be found two ways, for a regular cuboid and for an irregular cuboid. Now the regular cuboids can be found using length into width into height, while for the regular we take amount 50 ml of water, use transparent measuring flask measuring cylinder. We add a water, we record original value, volume for us 50 ml. Pour our irregular object in it, and now we change the volume water plus the volume object. Any volume. Now, a new volume is it combined with nothing. The volume of the water and the object. So, the remaining volume would be regular. So, we'll find the regular volume of your volume of your irregular object. And we will do regular, so we know a length with a breadth. Do that. 2 into 1, which is 2, and then 2 into 3, which is 6. So now we find volume. The volume is 2 by 6, which is 1 by 3, or 0.333333. The ones taking will float in the water because the density of the word is less than the density of Now let's go. Now let's compare some densities. So let's take air. So air is the lightest, the most less dense in this substance. Now let's take some substances and let's compare the densities with water. So the density of 1 gram per centimeter cube. Air has a density of 0.0013, which means the air in solid it actually flowed in the water. Oh, let's say okay, some more. The density of the wood is 0.5. Is that less than 1 or greater than 1? It's less than 1. If it's less than 1, then it will be floating. Okay. Now, ice. Water. So it is a very close density of 0.93. Thing is the volume is increased as another volume. If the mass was increased, it become higher. And having volume increased, it become low. Now we have aluminium. Aluminium has a density 2.7. So the mass by volume term here is 2.7. And then it is greater than 1. It will float on, sink in the water. So will lead and gold, which each have a respective number 3 and number 3 densities. And so the gold will sink. Now, ethanol is a type of liquid alcohol that floats in water. It only has 0.9 for density, so it will float since it's level 1. And so does methanol. I think, methanol will be not type of oxygen. Now let us compare the densities of different liquids to water. Now water is here. Now edible oil is way less than water, so it is above water. Edible oil being oil that you use in cooking, like olive oil, sunflower oil, oil used in cooking. You eat and have oil, not dangerous oil again. Now next we have water. It's made of value with 1.0, This was liquid. That's way more dense than water, so it sinks. It's way down. It's at the bottom of the water, but the density is not so much that it is going to be complete. Sugar syrup and honey have way more density than. Now sugar syrup has more density than was discussed, but less than honey. So it will be in the middle of both. Also here I'm sure the sugar syrup is iodide. It is sugar syrup because here adding sugar. And 2 density makes density increase. Again density decreases. The basic addition technique. That's why sugar syrup, which is dyed red, is way more dense than the frozen liquid, but less dense than honey. And on honey. Honey is not completely solid liquid, flour and sticky. And such because of that those factors, those adjective, those descriptions, those characteristics, honey has a lot and has a lot more, way more dense than water. I have checked density, comparing this solid and liquid knowledge, and our session we also comparing gases of different densities to water. Now, make such a way that we will take what is it's gram by liter, while this was gram by centimeter cube. Gram by centimeter cube is 2 gram to liter per minus 1. So it's not that authentically correct. But we know that air is very less dense. Oxygen is only one more dense than air. Now that it's something very far from these numbers. We know all of these numbers float and they become ice. Actually for carbon dioxide. today we'll say. So now hydrogen is the one that has least amount density from all of these. But helium. But now hydrogen is less dense than helium. Why are we using helium to blow balloons in hydrogen? Now, the reason for that is that hydrogen is flammable with oxygen, thus hydrogen cannot be used for blowing balloons. Helium can be used, and so we are using it. The helium balloon, you leave it by mistake, it just floats in the sky and never to be seen again. Yeah. Now, nitrogen is way less dense than air. So, that will have to float with air. And as we know that air has 0.003. It has maybe 0.1, 2, something like that. So yeah. Not so clearly. Point is to gram to cube because that's the graph I found. But based on here, it does the nitrogen less dense than air, and so it will also float. Now let us see that on much distance between oxygen and air. So oxygen also will float in water, and as the more dense the molecule, this but the carbon dioxide is very dense. And so way less than that. So we can see all this will float in water if made into solid. Okay. So now we have this one with this. So we started what is mass and volume. Then we figured out how to calculate volume density. Then we decided to compare entities of solids, liquids, and gases. Now my question is, how is this related to force and energy? Well, now for example, to make density we need that force, the energy to do it, right? So with the energy and stuff that we can calculate it. Let's go here. Now for two ways, right? So the second way, the first way mass, we need to use force on it to get the mass. So mass here needs the weight scale basically. That's why it's in kgs. No one uses energy and force so anyway because the volume equals I have here. This and not only this, there's still two parts where we will be discussing more. We'll be discussing I wanna learn about heat and temperature later on, kinds of energy, moving from hot to cold, and various and how evaporation can cool videos. So we'll have two more parts. So if and also if you like this video, click on subscribe button, like the video, comment, and hit the bell icon. And please smile and learn every day. And bye.